Hi everyone, Magius here from Awesome Tuts, and in this video we will create a space runner game in Unity. So you see that this is some kind of 2D platformer game, so we can fly, some kind of fly with our player, so jumping down and up. So we need actually to avoid these spikes here, to pick up these pickables, so on and so forth. Now I will try to win, and you see here that we have there some kind of portal or door that we need to enter, and we finish our game. But when I, for example, made a mistake here and go up, we see that we die. Actually, our gravity throw us in the air, and we kick on some of our spikes and we die. And that is our game that we will create in this tutorial, so stay tuned for that, guys. And now we are ready to develop this game from scratch. So you see here, when I open this empty project, I import there a couple of sprites and assets and so on and so forth. You will get that as always with the link in the description. So you see that we have there some tiles that we will need to drag into our scene. So for the scripts, we do not have yet any scripts here. We will have actually in this game, in this project, just the two scripts. So we will have just that two scripts for our plan and our camera, and that will be very cool. We have also there some prefabs that I also imported. You will get also this via the link in the description. So this is grid. This is actually our level. So when I import there, for example, this grid in our scene, you see how long our scene is, how big our level is. And now actually when we go here in our grid in the hierarchy panel, we have there as a children these platforms. So when I deactivate this, you see what are our platforms. And when we go here in the spikes, we see that actually these spikes are very long. We need actually to resize this to be just snapped on our platforms here on our grid. So I will do that shortly. And now I also snapped these spikes that we will need to avoid in our gameplay. Also we need to import there in our scene and that is the portal. So we need to import our portal, and this is going to be, so when I focus on this is going to be our door or our finish line. So actually we need to reach this portal, but we will not make in this tutorial winning effects, some winning panels, congratulations, so on and so forth. We'll just try to reach this portal and pretend that we are winning this game, because we will not have, I think, the time for that behaviors. We will be busy in this video with some kind of coding and multiple behaviors for our player movement. Okay, the last thing that I think that we need to import is these pickables here. So I will try to also snap these these pickables here, and yeah, I think this is fine. So when I a little bit focus on these pickables, yeah, we need to also a little bit drag up these pickables. And when I click here, yeah, this is going to be the crystals that we need to pick up in our game. To avoid spikes, to pick up these pickables, these crystals, call them however you want. And that will be our game. And also so I will go here in the, so again in the prefabs, excuse me, I didn't see our player here. And then this is going to be our cute spaceman player here. So we see that we have some missing script here. We are going to remove that, of course. Also animator, we do not want to animate our player also in this video, because we'll not have the time for that. This will be in some next tutorial. And yeah, we see that our player have this sprite rendered, rigid body, and of course capsule collider 2D, because our player actually have this capsule shape of him. Okay, everything is very prepared here. We import everything that we needed to import here in the scene, and then I will go here now in the scripts and create first one script, and that is going to be our player, and of course open it up in Visual Studio. So first thing first, in this script I will create 4 float variables, and that is our variables here. So first variable is speed. So this is, and you can imagine, the speed of our player. Second variable is our jump force, because we will also make an effect of jumping in this video. So we will make that our player can jump. And of course this horizontal and vertical movement will also be our variables for the movement, so we'll use also this. And rest 3 variables will be actually private and then sprite renderer, which we will simply name renderer. And then last variable will be our private rigid body 2D, which is the, of course, rigid body of our player, and we'll name this variable my body. And in the start method, we will initialize our two last variables. So renderer will be equal to get component, and in the angular brackets, of course, our sprite renderer. And then for the rigid body, the same way, we are going to get the component from our rigid body 2D in this variable, and we are good to go, guys. And now in the update method, we are going to use our horizontal, or actually set up our horizontal and vertical movement. So first one, horizontal, it is going to be equal by input.getAxis, and in the parentheses by hard coding we are going to pass horizontal, and then we are going to multiply that with our speed variable that we have created right above, and then we are going also to that speed variable multiply with the time dot fixed delta time, and we are going to copy and paste this function right here, so no outside of our update, so don't make a mistake like me in this case. And then we need to add or paste this line of code right to the update method, and then just to remove this horizontal, this is going to be vertical, also variable that we have created, and there instead also of horizontal there will be vertical by hard coding, and we will not going to multiply this variable with our speed and time dot fixed delta time in this case. Okay, now we are going to create one function on our own, and that is going to be move. So simply moving function, so no animator move. I don't know what's happening with me. Damn son, I sometimes make a very silly mistakes here in the spelling and coding in general. So private void moving function, and in this function we are going to optimize our horizontal movement, vertical movement, and jumping, and actually we'll make in this function that our player can move horizontal, vertical, and can jump also. Okay, now we are going to take our if statement, and in that if statement we are going to pass our mathf, and this is actually the library of our mathematical functions, so dot approximately, and in the parentheses, and you see actually that this approximately function is actually compares two floating point values and return true if they are similar. So we are going to pass here two float variables in the parentheses, and this will return the true if they are similar. So you will see that in an action later on, and everything will be understandable, I hope, to you. And then we are going to first of all choose or pass our horizontal movement, and then for the second parameter we will leave this as 0. And I forgot here to add also exclamation mark, so actually this now makes an opposite. I explained in previous tutorials what does this exclamation mark in the if statement means, so if you want to know that, simply check out my previous tutorials also here on awesometuts.com. Okay, now we are going to flip our player. So we are going to take our renderer dot x, so not just x but flip x, and then this is going to be equal to, in the parentheses of course, input, so no input, excuse me, there will be horizontal is less than 0. So don't worry, I will later on explain what I did here. Now I will once again copy and paste this function. I will move down this function, and this will be now for the vertical movement. So now we are, instead of horizontal, we are going to pass here vertical, and then instead of this line of code we are going to open one new if statement, and in that if statement we are again going to use this mathf library for the mathematical functions, and then approximately open the parentheses, and in the parentheses again, so no vertical, excuse me, we are going to use our rigid body dot velocity dot y. So this is actually the velocity on the y-axis, and then we are going to pass here a comma, and for the second parameter will be the 0. And what will happen in also this is going to be true, we are going to again open third if statement, and then in that if statement we are going to pass if vertical is less than 0 or our body, so we will again use our body, so my body dot gravity scale is greater than 0. So what will happen if all of these are true? So we are again going to use our rigid body, so that is my body dot gravity scale, and multiply equal with -1. And as I said, I will everything explain later on, but now we need to update our velocity. So we are going here between these two if statements. So this is for the horizontal movement, this is for the vertical movement, but there we actually need to update our velocity. So we'll go here and pass that we want to store our myBody.velocity, our rigid body velocity, to vector3.smoothDump. So we'll searching for the vector3 smooth dump function, and then you see that our smooth dump takes a couple of parameters. So takes a current position on the vector tree, target position where we want to go with our player, current velocity, and then float smooth time. So we actually have first two parameters, but we do not have, I think, second two parameters. So we are going to create that later on. So first parameter will be actually our body, so our body.velocity. Then second will be target velocity, and yeah, we do not have that variable, so we are going here below and we are going to create that variable. So this will going to be, so I actually forgot to add there a statement. So I know that there will be error, but this have to wait. So there will be vector3.target velocity. So target velocity is equal to new vector2. And for the first parameter will be our horizontal, and for the second will be our body.velocity on the y-axis. And this will be our second parameter here. So this will be our target velocity that we have just created here. And also we need to create our third parameter in this function, and that is our ref velocity. So we are going here and again create one new vector3. This is going to be ref velocity, as the title says here. So we need to create also this function, but this will be simply vector3.0. So if you don't know what this means, this is actually the whole shorthand for writing vector3 and then 0, 0, 0. So actually this is some static position. Okay, this will be r. So we'll pass here first of all ref, and then ref velocity variable that we have just created. And for the last variable, this is actually our smooth time. We have that time, and that is 0.03f. So simple as that. And now we updated our velocity. So this is for the update of our velocity. This is for the horizontal movement, I repeat, and this is for the vertical movement. And last behavior and piece of code that we will code here in this move function is actually our jumping behavior. So we are again going to open this if statement and then again use our mathf library. So where is the mathf? Yeah, there it is, approximately. So this is our command function in this script, and then in the parentheses we are going to again use our rigid body. So my body.velocity.0. So not dot 0, excuse me, this will be dot y, so excuse me, and the 0 is actually for the second parameter, so I got confused. And then what we'll do if actually our body is similar to this 0, so meaning if we are on the ground, we are going to jump just if we are on the ground, and just in that case we can jump. And for that we use there approximately, that actually, and I repeat once again, compares two floating point values and return true if they are similar. So if our body on the y-axis is similar to 0, we are going just in that case to jump. So meaning we are on the ground and we can jump. So then we are going to again open this if statement, and in that if statement we are going to pass here input.getKey, and in the parentheses key code will actually be space. So we are going to jump with by typing on the space button. And actually we are now going to make a jumping effect. So we are going to use our vector3 direction. So we'll name this variable direction, and then this is going to be equal in the parentheses. So my body again dot gravity scale is greater than 0. So what will happen again if our gravity scale is above 0? So actually that means if we are on the ground again. So if we click space and we are on the ground still, we are going to pass here an question mark, and don't worry, I will explain what this means. And we are going to use this vector3.up, and then we are going to use these two dots actually, and then pass again vector3, but this time down. So don't worry, I will explain what this means. This actually means that when we are on the ground and when we click the space, so when we are, again I repeating, when we are on the ground, if our gravity scale is above our 0, meaning we are on the ground, our gravity works, then we are going to execute this vector3.app. So now in that case we are going on the app, and if this is false, if we are on the air, for example, this will be executed. And I don't know why I get there an error, but we will proceed and ignore that for now. And yeah, our error of course gone. So we are going to again now adding a force to our rigid body in order to we can actually jump, and in the parentheses we are going to provide our jumping force that we have created in the variables, multiply that with the direction that we have just created. And for the force mode we are going to use, so force mode 2D and then impulse. So then we are adding a force to our rigid body by jumping force to the direction that we specified here, and I think I explained what does this means here. And then force mode is of course our impulse, so that is the add an instant force impulse to the rigid body 2D using its mass. And then I think guys everything here is understandable to you. Last thing that we need to do here is going here and create void and then fixed update method. So I explained, I think in the previous tutorials, that we use this fixed update for the functions where we use physics, and definitely in this function we use a lot of physics, and for that we are going to, instead of update, call this function in the fixed update, and this will work smoother and better than in the update. Okay, now we are good to go. Saving this, go back to the Unity, and I think we are good to go with the testing. But before that we need to attach this script on our player. So I attach this script on our player that we have just coded, so don't forget to do this, otherwise this will not work. And for the jump force we are going to pass here 15, because I think this is going to be a nice variable value for the jumping force. So now also don't forget to optimize their rigid body and capsule collider like I optimized here. So you see that actually the gravity scale here is 5. We put the collision detection is continuous. We put everything here is fine. So dynamic, simulated, mass is 1, mass linear jack and angular jack we put it to be 0, and everything is very cool so far. So now I will simply go here and play our game. And yeah, we see that actually our player gets thrown in the air, or call it however you want this behavior. We do not want this. So I think I created here for our player one physics material. So we actually see that we do not have any physics material to our player. So I created here, so when we go in the assets, I created this tile M, which means simply tile M material for the tile. And then we use here for the friction, we put friction on the 0 and bounciness also on the 0, and we are going now to drag and drop this tile material to our rigid body, attach this tile material to the rigid body, and we are good to go. And actually this wasn't the problem for this behavior that we get in the gameplay. When we go in the Visual Studio, I found that we do not put here exclamation mark like for the horizontal movement. So actually in this horizontal movement we put exclamation mark there, which simply means if this is opposite, we are going to execute this. And then we actually forgot here to add exclamation mark here in the vertical movement, and for that we get the effect that we have get previously. And now simply add here exclamation mark, save this, and I hope we fix the problem. So when we go back here in the Unity editor, now I think we are ready to test this game once again. So I will simply play our game. So now everything is fine. We can flip our player. When I actually hold our left or our right actually arrow, we see that we go right. So we are going to again specify the floating value speed for our player, and actually we see that everything works. When I click the left arrow, we are going left, our player face the left side, and this is the effect that we wanted to create. So simply go back to the Visual Studio, and our player is very small because the speed actually is just a 2, and we need to actually increase this definitely in the value. So we are going to pass here, for example, 150, and yeah, I think this will be this is going to be the nice variable value for this behavior. Okay guys, everything is so far good. Now we need actually to detect the collision between our crystals, our pickables, and our spikes. So I will go here below our fixed update and create one mono behavior method, which is the on trigger enter 2D. So I will pass here on trigger enter 2D, and this is actually the method for the detecting collision between trigger and non-trigger game objects. And yeah, I will use here again if statement and pass here if our collision dot tag is equal to spikes, for example. So first we are going to use our spikes. So if our collision dot tag, meaning if our player touch our spikes, we are going to destroy our player. So we are going to simply pass here game object dot set active false, meaning we are died if we touch our spikes. And then, so I made a mistake here, of course. I will copy and paste this, and I will move down a little bit, and then I will pass here if our player touch our pickables. So like these pickables, in that case we are going to use here collision, so no that way, but collision dot game object dot set active false, and in this case we are going to destroy our pickables, because now we pass here collision dot game object dot set active, meaning destroy these game objects here that is tagged. But in this case we definitely destroy our player. Okay, I think also this is so far good, so I will again save this, go back to the Unity, and now when I go here and play our game, and yeah guys, we are in the gameplay, and actually we see one gap, and that is our camera doesn't follow us. So when we can test this vertical movement, so you see that this is some kind of gravity changer, gravity mix, and so on and so forth. So very interesting facts with the gravity we prove here in this game, and we create actually here. And guys, I am very satisfied with this movement, with this vertical and horizontal movement behaviors with the jumping. So when I click the space button, we can also jump here, we can jump even here. So even here when I go here in the vertical movement and jump, we jumping. And yeah, that is so far good guys. Now we are going to also create the effect of camera following, in order to we can go in the space where our pickables and our spikes are, in order to we can detect the collision and test our collision with that two game objects. So I will go back here, go to the scripts one more time, and create camera follow script. So I will simply name this. It's a little bit thunder in my town, so sorry about this guys. If you actually hear some strange noises, this is because it is very thunder in my cute little city, and for that you hear these voices, but we will proceed with our develop without problems. So I will create here camera follower script, and we are good to go. And now in this script we will have just these two variables. And so first variable is actually the reference for our player, so public game object our player, and second variable will be the offset, or actually the distance between our player and the main camera. So we will go down here in the start method, and then we are going to set up our offset variables. So this is going to be, we'll take now current position of the camera, and then we are going to subtract that with the current position of our player. So player.transform.position, and you see that this offset is actually the distance between our camera and our current position of our player. And in the update method, we are going to use our transform.position, the current position of our camera, and then store that in the player. So transform.position, store that in the current position of our player. We are going to add on that variable our offset, that is a distance, as I said, between our player and camera, and this is going to be the transform position, or actually current position of the main camera. This is going to be this result. And actually via this code our camera will follow our player. So we'll save this, go again back in our Unity editor, attach our camera follower script on our main camera, and you see that we have there some empty slot that is for our player, and we will drag and drop our player here in this empty slot, and I think we are good to go. So before this final testing, we are going here in the assets, and I forgot of course to import or drag in this scene, in the scene, this background that I prepared. So when we go in the game we'll see this, and everything will be nice for our background. So everything will be nice guys. So I will a little bit position this background here, and in order to our background follow our player, we are going to put this background as a child of our player. So simply put that background, and our background will always follow our player. So we'll see how good that effect is. And yeah, everything's fine. For the final testing, I'll play our game. And now we can move with our spaceman here, and I will try to, yeah, I pick this first one, obstacle or pickable, excuse me, and we see that this works. So when I again go here, and when I now jump down here, yeah, I pick also the second one. When I jump here, yeah, we jump here in the spikes and our player is destroyed, and guys, everything works. I'm very glad that I present to you this game. Yeah, everything works. I also mentioned to you that we will not create some winning effect because we do not have time. Also, this video gets too long. We coded everything that we needed to code. The main part here in this game was our player movement. I think I explained everything to you. This code in player movement script is understandable also to you. Yeah, everything is very cool, guys. This one space runner game, that's very cool game. And until some next game, see you guys.